Cool. Great to be the second speaker of the day. It's the moment when everybody finally arrived and hopefully woke up after the first coffee of the morning. Thanks for a great talk. It's a pleasure to be here at the first iOS conference in Singapore. My name is Bogo Giertler. I'm originally Polish. I currently am an iOS engineer at Dropbox in San Francisco, California. Until earlier this year, I was working at Spotify as a UI engineer. So if you enjoyed your music in a really pretty style, that was my baby. Let's talk about things that are not going to be part of today's presentation. We're not going to be talking about testing code. We're not going to be talking about shipping betas. We're not going to be talking about tracking crashes because his company does it perfectly. Although we have to talk about the web UI thing later. We're not going to be talking about localizing the app because all of you should be already doing it. We are not going to be talking about setting up analytics, things like this, also crash analytics right there. Modernizing your infrastructure, having a build infrastructure, changing your patterns. We're not going to be talking about this. What we will talk about is a little bit of science. So we'll start with XKCD. We'll start with talking about some scientific instance of tech debt, like very, very serious tech debt. There's this word coming from Greek, ether, and I have no clue how to actually read it in Greek or in English. I just guess it's ether. But the idea of ether as a untouchable essential substance that permeates the universe, sometimes known as the void, sometimes as the ether, it's very ancient. Basically, every major philosophical movement in the world had it at some point, except for the Chinese, as I found out yesterday when I was looking up it in Wikipedia, although Wikipedia might be wrong. So in 16th century and 17th century, there was massive amount of research and about light, gravity, and so on. And since then, there was an idea of a luminiferous, I have no idea how to read this word, luminiferous ether, a matter permeating all throughout space, providing a medium through which light could travel in vacuum. Because it was kind of unclear. Light had qualities of a wave, of sound in certain instances, but it was not moving through any medium. So they had to explain it to themselves using an extra factor, ether. So there are those two really smart guys, Newton and Riemann. Riemann was invented a major part of modern calculus, and obviously we all know what Newton did. And they were actually researching a lot how ether might be affecting gravitation, might be affecting light, in Riemann's case, and gravity. And then there was the sweet summer of 1887, where two guys, Michelson and Morley, decided to do some science, and they were not putting needles in lemons to get light. Instead, they built this really crazy apparatus to measure the relative velocity of ether. The idea of ether was that it doesn't interact with anything, so it's not a chemical reaction. You cannot touch it. It's just there. You have to believe it's there. So they figured that if Earth moves through ether in one direction, it will be going with the ether, and the other direction will be going against ether. So if the velocity of light is constant, they would be able to measure a change in the speed of light. So they did the experiment. They were expecting to get a value, find out what is the relative speed of ether, and they had this soul crashing result that the experiment was actually negative. That the result was negative. They didn't get any ether, and ether turned out to be the singleton of pre-20th century science. It was the first strong evidence that the ether theory, after 200 years of heavy work on physics involving ether, that this thing doesn't exist. It was dead. And there was a huge amount of technical debt there because physics was all built up to this point on the idea of ether. But physics and science survived just fine. So why am I talking about Michelson Morley experiment at an iOS conference? Because in our line of work, we have to face a very similar kind of problem almost every day. There's this great artist, Sid Meier. He was a concept artist responsible for design direction in many of cult classics of science fiction, in Blade Runner, in Aliens, in Tron. He said that we don't go into the future from zero, but rather we drag the whole past in with us. And that is particularly important if you want to maintain sanity in your code while writing your code. First of all, the group of people you write it with, your team, you need to maintain the culture of people. There are two cultures that I'm particularly fond of. One of them is the culture of people. Your constraints evolve every day. The problem you work on today is not going to be the same problem you're going to be working on in 3 months. So, when Michelson and Morley provided data that Ether didn't exist, nobody, went back and started drawing idiot hats on Newton and Riemann. Newton and Riemann were considered to be fantastic scientists, but they were working with a very different set of constraints, very different understanding, different perspective, and for them, the Ether approximation was good enough. Instead, we as developers very often, go straight for git blame, which is, in my opinion, even more dangerous than rm-rf/, because actually we tend to jump into git blame. It's a useful tool to find out whom to talk to when something looks really weird in the code, but it's totally unhelpful when you want to judge the skill level of your peers. So first of all, assume your coworkers are smart. More often than not, they're the people who hired you, or you are the person that hired them. So how can you actually improve the relationship with coworkers? How can you work in a large team of 20, 15, 20 engineers or iOS engineers? One of the things is to establish a great code review process. Just as in science, you have peer review of your academic papers, of your submissions. So you do have a similar process in software engineering. And review quickly. Respect the hard work of your peers. You don't want to be the tip of a feature idling and waiting to be merged while master is moving swiftly forwards. As I put it there on the slide, friendships die in code reviews. And because friendships die in code reviews, and I'm 100% serious about it, just like mathematics has a clear notation pattern, so should have your code. Agree on a code standard. Just use linter if you have to. Just have one holy code standard under linter and minimize the number of friendships that will die. It will feel weird and uncomfortable in the beginning because it might not be what you're used to. But you will avoid tons of those arguments when onboarding a new person to the company, being like, oh, why do you use ivars instead of properties? Or why do you put 2 spaces instead of 1 tab? You don't need those arguments. That's syntactic sugar. That's opinions. Opinions are useful, but they will not help you. They will not help you develop actual better code in this situation. At Dropbox, we use a combination of hand-rolled Python scripts for linting. We do things like sorting our imports alphabetically, and then we use a very well-configured Clang format to actually get what we want. That thing runs together with unit tests right before checking the code into the repository. And it seriously decreases the amount of any discussion you later have. You can actually abandon the false safety of pointing out whether somebody has too many spaces or too many returns in code review, but rather focus on what the person is actually trying to say. Focus on the meat of the problem. Then make sure you do have plenty of header documentation. It is really the best gift you can give to your peers, to your coworkers. Header documentation is the best asynchronous method of communication you can have in any code base. My experience with Spotify was that 25% of our UI framework code was actually comments. Like if you ran clock on the UI framework code base, 25% of lines were straight up comments. And that helps because you do create a very strong sense of good API and clear understanding of what your classes and your tools are doing. Requests for opinion are your friend. If you work in a distributed team, which I assume many of you are, you have maybe designers somewhere abroad or some engineers are based in a different country, you should be using something like Slack, HipChat, mailing list, even a private Usenet server. Share your opinions, share your suggestions, share what you're going to be doing. Don't just surprise people with unleashing a huge change in the project on them. Actually have a conversation. Even if it's just to notify people, it's a great practice. And show your tasks. I cannot stress this enough. It's important. Again, use whatever tool you feel comfortable with, whether it's Trello, whether it's GitHub issues. Please don't use Jira. Or Manifest or something. Manifest is fine. Actually, show your tasks, mark them as done. Have people have clear understanding where you are. You might not be having a manager in your company. If you're working in a small team, it's probably you and a couple of your friends or close coworkers. But it does help everybody stay on top. It minimizes, again, the amount of noise, the amount of questions. Everybody can focus a little bit better and work a little bit faster. And there is another thing, which is the relationship between designers and engineers. I know many designers have fantastic relationships with their engineers or vice versa. But then I know of certain situations where people actually left companies because of their ongoing conflicts with designers. Designers consistently want to move the quality into their field. Engineers, different kind of quality into their field. So you play the kind of tug of war, which looks something like this. Is it visible? Yes. That's basically how you feel, I guess, whenever you're being told to move something 5 points to the left, or you should capitalize the first letter in that string because it looks better, right? Like, people are going to give you 2 stars if that button is going to be 5 points off. So don't be a tool. Just write the tool for the designer. Help to bring the designer on board. At Spotify, we had this fantastic tool that let us prototype and change the contents of the UI very, very quickly. We could replace any color, we could replace any font, placement of any item, run it on a live phone or run it in a simulator, just do it live. So you could just sit down a designer and have them tweak all the colors to perfection. It sounds a bit like what folks did at Apple for Steve Jobs and his calculator, but it actually does work really great. So now that we discussed the culture of people in the company, it's a good idea to talk about the culture of craft, of things that you actually do every day. So when you start your project, you probably start with a bunch of really neat classes. You have like a super class and a couple of subclasses. And then you add some categories, and maybe you add an extension here or there. And you decide it would be good to add some more super classes and swizzle some things in. That's the orange thing on the bottom, which you should not be doing probably. And then things change even more. And I don't know if you guys see where it's going, but you kind of end up with Australia, where everything is trying to kill you. Do not end up with Australia. But the thing is, you will end up with Australia. Like, that is the nature of software engineering. You will be planning very well, and one day this platypus or something is going to sneak up on you, and it's going to get really crazy. So the way you can actually solve this problem is by blackboxing the hell out of everything. You should be thinking about your product in the highest possible abstraction tier you can afford. Chris Parker said on last WWDC, session 416 specifically, for those who would want to look it up, Designing Modern Frameworks, that API design is basically like contact sport. If you're not throwing some elbows, you're probably not having enough fun with it, or you're not doing it good enough. Do we have it? We have it. So in your APIs, express your intents clearly. Your API is probably the only chance you really get to have a conversation with your consumer. Don't do something like cell.imageview.image equals that image, because that's your data, so you really need to be aware of how you implement the presence of image in that cell. What you really probably should be doing is cell.image equals that image. That way you can replace the way image is displayed with banana kit or whatever else thing you want to implement there. Nobody really needs to care. You have a strong API that's not going to change as you change the implementation details of the class, and your consumers can live safely. You don't have to worry about versioning, updating, and so on. Then again, minimize the amount of contact points. You don't really need a separate NS array of items and an NS integer that has count of items, because your engineer is smart. They can do array of items.count. And by minimizing the amount of those contact points, you minimize amount of code that you actually need to maintain, minimize amount of trouble there. And that gets contentious, but APIs are clear APIs, flat APIs are a great way to improve your code hygiene and collaboration with other people. A lot of older developers on your code base will have a good understanding of bits and pieces of the subclass inheritance tree, but tracking down the issues for your inheritance tree, composition, God forbid swizzling, this will become a huge headache, especially for anybody who's joining your team if you don't have documentation readily available. Protocols are a perfect way to resolve a big part of it. It lets you abstract stuff out, makes your life super easy when it comes to implementing tests. I strongly believe in it. Again, if you want to discuss it, come by later. I will try to convince you I'm right. Now, another thing that I found was a great idea. This is a sample from Spotify, but similar pattern exists at Dropbox. That's the whole black boxing approach, where the UI framework was completely separate, testable piece of code from any other feature code, which was running completely separately within a larger kind of operating system of the application. And everything of this was running on top of a common networking and playback code base. That let us test everything extremely well. We didn't have to worry really about the interaction between the UI and the backend. Nothing ever talked directly. It spoke through a bunch of layers of abstraction, and each of those layers could be tested very well. But now I'm telling all those nice things, and you do end up with a broken Windows problem. And if you didn't read the Tipping Point or one of those books, the broken Windows idea is that idea from James Wilson and George Kelling. In 1980s, they were analyzing the situation in New York, the safety of New York, and the idea was that if a building has a bunch of windows that are shattered, it is more likely that this building is going to attract further attention of the unkind kind. So there will be more damage, more graffiti, so on. And there is a similar situation that will arise if you actually don't pay close attention to your code base. If you stop putting tests in, if you stop documenting, it kind of gets, in my mother tongue in Polish we say what's out of eye, it's out of heart. If you don't really pay attention to it, if you stop noticing, you stop putting it. If your build server does not notify you that your coverage is dropping, you're eventually going to stop doing it. So yes, make sure you have as little broken windows as possible. Singapore is a great example of how this problem is solved. No chewing gum anywhere. So yes, and then counteract the momentum, or rather the lack of deriv. In many cases, when folks start on a new feature, on a new project, new bigger class, the problem is that you don't really know where to grab, how to start climbing, and it is important to note that Rome wasn't built in a day. Neither was your HDB if you live in one. Neither was iOS, AF networking, Alamo Fire, Snapchat, you name it. I mean, Snapchat actually might have been built on a hackathon. It doesn't look that complex. Case in point, though, whatever you're working on, it might look unsurmountable, like El Capitan, great idea that Apple put it on their new operating system, but you will eventually find a way around it. And the best way to get going is to start asking questions. If you are working on something, you will be asking those questions to yourself. If somebody is requesting the feature, you will be you should be speaking with them. Jeff Atwood has this great quote that having the guts to ask basic questions is, ironically enough, a hallmark of the best developers he's ever worked with. And that's very true. If you ask many questions, if you can set a very clear set of expectations, that is insanely and extremely helpful. So I'm saying all of this, and you might be like, yeah, that's a cool story, bro. Like, we are a 5-people company, everything is going great. We really don't need it, or we can't afford spending time on building complex technical solutions, have like a theming system or something like this. And that is very true. A lot of this stuff already exists in open source, in free available forms. For theming, you have things like Pixate. which you can just download for free, apply a theming engine to your application. For building an A/B testing solution, if you want one, you have something like you can build it off Parse or build it off Amazon Web Services. It's really simple. It's very affordable. It's there for free. And I think it's important to notice that we do tend to bestow upon ourselves titles of people like developers, engineers, makers, ninjas, all kinds of words associated with mastery, with craft, and with solid work. So we should strive and aspire to live up to those words. All non-trivial abstractions, though, are to some degree leaky, as Joel Spolsky pointed out. So whatever I just told you, I'm not saying this is complete certain truth, because software engineering is not an exact science. Sometimes approximations are good enough. Often imperfect abstractions be perfect solutions. The choices are actually yours to make, and I do hope that in this presentation I gave you a couple of ideas on how and what to choose. I did run through this presentation rather way faster than I trained for. There's plenty of time for questions. Thank you very much.
Yeah, anyone has questions? Anyone? Calling once?
I have maybe another question. Do you have any experience with going different sizes of teams and changing in dynamics in the team? So if you have a small team, you start out with 5 people, then you team grow, and
right.
Get to 20, and I don't know how big Spotify and Dropbox are. I'm pretty sure that they go. Do you notice anything different dynamics of it?
Of course, I mean the dynamics will change. I was at Spotify and was growing from maybe 15, 20 committers to the code base to something like 40, 45 committers to the code base. So that's a pretty big iOS team. The dynamics definitely change, and the fact that you can atomize your product into parts is definitely helpful in the dynamics. There is never going to be one person that is able to sort of hold the project in their head. I mean, people might have a good idea of how the puzzle pieces fit together, but they will actually most likely not know how every single piece fits with the other piece. So what I would say, as your team grows, you should be looking more and more into the black boxing that I was suggesting. If you can have people with specific work items, with specific projects to work on, they can specialize in, that is going to give you a lot of help. Because they're going to be the clear point of contact in the future. They might not necessarily need to work with it 100% of time, but it's definitely super helpful if you can have a master of a specific part of your application that you can refer to.
Great talk. Thanks for talking about this. I think it's super important. For me, one of the hardest challenges as a developer hasn't been technical. It's exactly this. And I wanted to ask you your thoughts about, I think, one of the hardest situations, having a team where you have these two ends of the spectrum, like the extreme end of move fast, break things, the famous Facebook motto, and let's move slow and do things right and not end up buried in tech debt in 6 months and rewrite everything. Like when you have developers, team members that have these two ends, like how do you make that work?
That is actually a fantastic question. So I think a lot of this comes down to the culture of the company you're working in. And if you're growing your team from 5 to 10 to 12 engineers, a lot of this culture and then beyond it, a lot of this culture will appear spontaneously. And some of this culture might be in larger teams instilled by the company. So in case of Dropbox, the approach, there is one of the company values which is sweat the details. It is actually to make sure that you ship it basically when it's perfect. The approach to, in my personal opinion, to move fast, it's a perfect approach to prototyping. You need to build a small tool for doing theming, just move fast, break things, have a good time. That's what engineers love doing, right? It's building cool stuff that actually kind of works, and then you're going to fix the bugs later or rethink the architecture. But when you have it on a team, there is this argument that you really need sort of solid people who are going to be focusing on making sure everything is running and is sort of well-oiled. And then you need people who actually are the disruptors, right? So they're the ones who want to change code standard again and again and again. They're the ones who want to try this cool new framework, put reactive Cocoa in it. And I think while they may get frustrated, especially in a team that is larger, so it tends to move slightly slower and makes decisions definitely more by consensus. They do instill a very healthy sense of discussion, because you do need to discuss those things. Nothing really beats having a conversation with your team. That's why I was saying that you really need some sort of synchronous or asynchronous conversation tool with your team. Whether it's Slack, whether it's a mailing list, you do need to talk.
Okay.
Yeah. What do you guys know about the switching from Objective-C going all the way to Swift? Because you've been into great companies like Spotify and Dropbox, so I'm pretty sure you code, like if people code base is not already moved to Swift. Maybe I'm wrong, but how do you manage to move that? Because Swift is not, but a couple of years old now,
right?
And probably a lot of people started implementing or doing it maybe this year because we were not ready for it. How did you go, like the companies per se went into moving, taking that step?
Again, I think it's very company specific. How to put it? When I was at Spotify, when Swift was just introduced, there basically was a company-wide ban on using Swift, like immediately. It was like nobody's going to use Swift, and I think that might have changed over time. But I think this is actually, if you have a large team of very smart people working together, paradoxically, this is a very good thing to do, to not use Swift. I mean, no offense, Swift is a fantastic language, and I love writing in it in my spare time. But when you have a big team of people, it is important that everybody is as close to the same page as possible. I mean, you will have more senior people on the team, you will have more junior people on the team. But with Swift, you still face the issue that some excellent developers who are very invested in the application did not pick up Swift or did not pick it up fast enough. Then if you have pieces of code not everybody can look at, and they're sort of specific knowledge domain, and you can write Swift in a very, very terse way. Specific knowledge domain of only a couple of people in your large group of engineers, that becomes a problem. It increases your buzz factor, which, if you don't know what buzz factor is, it's how many engineers need to be hit by the bus to actually bring your company to the standstill. Like, you want the buzz factor to be as high as possible. Basically, everybody should be able to work on any part of the code base with enough onboarding. So long story short, how do you handle this transition? On a small team, I guess it's way easier because you can actually make sure everybody learns Swift at the same time, or everybody works in together. You have a team of 40, 50 engineers. Adding piecemeal small pieces of Swift, building new frameworks, that's great. I wouldn't recommend trying to push massive, 15,000 line piece of nostalgic old code from your code base into Swift. At Dropbox, for example, we do support Swift in clients. There is I think the name of the library is SwiftyBox. It's basically or DropSwift, one of those. It's Swift bindings for Dropbox. So the language is supported. It's just not internally supported everywhere yet.
Okay, if there's no other question, then thank you very much.
Thank you.